Okay, hey guys, so the next lesson is 16D. It's called Rates of Change, and it's kind of straightforward. The first thing I just want to talk about is in this class, y is a function of x. So what's going on? What do I mean by that? Like every equation is going to be like y equals, 2x squared plus 5x, or y equals sine of x, plus 3, or, y equals, I don't know, e to the x plus 2 minus ln of x. But the idea is that you have a y equals something to do with x. That's the idea. So when we talk about, so we say that y is a function of x. So when we see dy dx, what we're saying is that the idea for this is how fast y changes when x changes. That's the idea. Now, what else am I talking about? If they use different letters, just go back to the idea is that y is a function of x, right? You might see in other classes, height, equals, I don't know, height is a function of time or something, So but you might see ht, but the idea is it's a y and an x. Okay, so then it just goes to some algebra stuff. Like they'll say, find the gradient of y equals 4x cubed at x equals 2. Now, in the last class, you learned how to find the gradient at any point. So you're like, fine, take the derivative, which is 12x, and then substitute x equals 2. You get, so at x equals 2, the derivative is 24. That's it. They might switch it around a little bit. They might say, find the value of x for y equals x cubed minus 7x plus 1, which has a gradient of 5. So what I want you to do now is I want you to go to Desmos, put this function up, kind of sketch it in your notebook, and I want you to think where you think the surfboard has a slope of 5. Okay, so this is my sketch. It's not the best sketch in the world, but I'm looking at the sketch on Desmos. I can look at it on my GDC, make sure you know how to do that, and then you're thinking, okay, it's kind of here, I'm not really sure. Well, what do? Well, they're saying, okay, let's take the first derivative. So dy over dx equals 3x squared minus 7. I want to know for what x value this is 5. Set it equal to 5, and it's just an algebra problem. 3x squared equals 12, x squared equals 4. You can go a little faster if you want. X equals plus or minus 2. You're like, okay, that makes sense. You're like, oh, I see that. You're like, okay, that's where the tangent line equals 5. Okay, the next part of the unit, we discussed this the first day. We discovered that if the slope of the tangent line is positive, that means that the function is increasing, and if the slope of the tangent line is negative, that implies that the function is decreasing. In this unit, we're not, well, actually, they might ask some questions about when the first derivative is 0. We saw that it was neither increasing nor decreasing. So the question is, find the range of values x for which, are we in there? Yeah, for which the function, which equals 2x cubed minus 6x, is decreasing. Right? So think about this, put it on pause, and then we're going to answer it. So, okay, we're back. So the second they talk about where it's increasing or decreasing, you're like first derivative. Like just, you have to know, is this on? Yeah. You have to know how to take the derivative. Like it has to be second nature, literally like adding or multiplying. So you're like, fine, the first derivative equals 6x squared minus 6, right? I want to know when it's decreasing, so I want to know when it's less than 0. Personally, the way I would do this is I would do a sketch. Well, you don't have to do a sketch because you know what? I know this is the parabola. So I know it kind of looks like this. I know it crosses the x-axis at 2 points. Let's see, you know what? 7 equals to 0. Go back to algebra if you want. So it's minus 6 equals 0, 6x squared equals 6, x equals plus or minus 1. I know that those are the zeros. I know the y-intercept is negative 6. I know this is a parabola. When is this parabola less than 0? Oh, between, so it's decreasing between, nope, sorry. It's decreasing between, but not including, -1 and 1. Or you can say it's for all x values such that x is between, but not including 1 and -1. That's the idea. Let me go in notebook. What else is in this little unit? They talk about find the rate of change. Find the rate of change. The second they start going on about the rate of change, you know you're taking the first derivative. Now, the reason I started off this unit talking about like the x's and y's is because they say a equals radical s. The second you see that, you're like, okay, y, in your mind's eye, secretly see this as like y equals radical x. But you don't need to do that. You can, say, okay, no, I know that a is a function of s. And they say, find the rate of change. Find the rate of change of a when s is 9. The idea is that we're finding this, like the slope of the surfboard, the rate of change at this particular point. Once again, we're going back to the theoretical. Before, we found the distance, the slope between 2 different points. Now it's like, hence they sometimes call it instantaneous rate of change. I want to know what the slope of I want to know what the gradient is at that point. I want to know what the slope of the surfboard is exactly at 9. And let's draw a picture, actually. Yeah, I want to know what the slope of the rate of change is at 9. So I know that dA over ds is equal to 1/2 s to the -1/2. And when s equals 9, I have 1 over 2 times 1 over the square root of 9, which is 1/6. So at A, it's changing at 1/6 when s is 9. On page 544, there's something about like ddx as an operator. I'm going to be talking about that in unit 18D. But for the rest of the unit, when I say derivative, you're like dy dx, dA ds. We're going to talk about exactly what the symbol means a little bit later. You can read it on your own. That's fine. Let's look at this the last part is about the second derivative. What is the second derivative? Well, for those of you who are going to engineering and stuff, you need to know about the second derivative. Let's see, the second derivative. So, second derivative. So, I give you a function. F of x equals 5x cubed minus 4x. Well, what's the first derivative? You're like, okay, f prime of x, also written as dy dx, and you're like, okay, that's easy, 15x squared minus 4. And you know how to do that because you've taken the derivative over and over and over again. Now I say, what's the second derivative? So you say, okay, I'm going to just do this again. So it's 30x minus 0 because the derivative of a constant is 0. The notation, it's going to look a little weird. We'll talk about it a little bit later. It's actually d squared over dx squared and then the y. Don't ask. We'll get to it a little bit later. So the question is, what exactly is the second derivative for? Let me summarize that for you, and you can take notes. Let's just use these symbols. If the second derivative is greater than 0, because you know these are algebra problems, and I'm going to say, you know, when the second derivative is greater than 0, we say it's concave up, right? And the idea is that the curve looks something like this. And even more importantly, the idea is that the surfboard is underneath the curve. Kind of interesting. If the second derivative is negative, we say it's concave down, and the curve actually looks like this, where the tangent line, or the surfboard, is above the curve. So the tangent is below, and then for this, the tangent is above. Concavity, that's the idea of, so an important word is concavity. Right, and now, most of this stuff isn't showing up, and then the last part is they say, so we see that the second derivative is actually the derivative of the first derivative, right? Because that's what we did. We had the first derivative, and then we took the derivative again. So this is like, this actually is the rate of change of the rate of change. The rate of change of the rate of change. And you know that as, anybody know it? Starts with an A. Acceleration. Acceleration is the second derivative of distance. Velocity is the first. We'll talk about this in a later unit. Velocity is the first derivative. Acceleration is the second derivative. That's it. 16D.